morning, grade 11 Saad. Today we want to start with our new chapter, chapter 6, Circular Motion. Okay, girls, what comes to your mind when you hear this word, circular motion? I will tell you. Look at these examples. In all these examples, what you can see, circular motion, roller coaster, merry-go-round, cars uh, in a curve, and girls whirling an object with a string. All these examples are about circular motion. This is the thing that is common in all these images. So today we are going to understand this type of motion, to study everything about circular motion. Okay? Focus with me, please. What we're going to talk about in this chapter, we will describe the characteristics of uniform circular motion, distinguish between period and frequency, determine the magnitude and direction of tangential velocity and centripetal acceleration for objects. The last thing we're going to do is to solve dynamics problems involving uniform circular motion. You remember before? Yesterday I told you that chapter 5 is very important, and this chapter depends on chapter 5, and also the next chapter depends on chapter 5. Okay? Chapter 5 dynamics. So that's why you have to study it very well before you watch this video. Let's start. Uniform circular motion. What does it mean? When do we have a uniform circular motion? When an object is moving at a constant speed, but changing velocity. How? How constant speed and changing velocity? I will tell you how. Because velocity, what does it mean? Velocity, it's the speed and direction. Speed is constant, the magnitude, the number. 2, for example, 2 meters per second. This is the magnitude, it's constant. But the direction in circular motion is the thing that is changing all the time. If you have a circular motion, what is the thing that is changing? The direction of velocity. Okay? That's why we say that in circular motion, speed is constant. Velocity is changing. Okay? Please focus. When an object moves in a constant speed, the magnitude of velocity is also constant. Yes, constant speed, it means magnitude is constant all the time. The object here, the object here, the object here, the object here, all the time, the same velocity. The same speed. Velocity is a vector quantity. It depends on both magnitude and direction. Objects move in circular motion are continually changing direction. Clear? So the magnitude of velocity is constant. The direction of velocity is changing. That's why we have velocity. Good? Now the acceleration of an object in uniform circular motion has constant magnitude but has changing direction. The same thing about acceleration. We are going to talk about acceleration later in details in this chapter. But here you have to understand also that the acceleration has constant magnitude but changing direction. Okay, so we have acceleration in circular motion. The magnitude of it is constant, but the direction is changing, and all the time the direction is what? Toward the center. At any point, the direction of acceleration is toward the center of the circle. This acceleration is said to be uniform. Why it's uniform? Because it has a constant magnitude, value, number. The direction is all the time toward the center. Okay? Good. Now, period. What does it mean? Now, objects that are moving in circles, here's a circle, objects that are moving in circles return to the same location every time they complete one cycle. So this one round, what do we call it? Sometimes in circular motion we call it one cycle, one circle, one revolution, one rotation. So when you hear any of these words, you have to know that we are talking about what? Circumference of the circle. One circle, what does it mean? The circumference of the circle. I start from this point C, for example, then the object returns to the same point. So this is what circumference. This is what one circle, one cycle, one revolution, one rotation, and so on. Okay. So what does it mean, period? Period is the time to complete one cycle. So how much time it takes from the object to finish one cycle or one circle or one revolution or one rotation. Okay, so here for example, the object starts to move from C. When it comes back to C, how much time it took from the object to finish one circle. How we find the period? The symbol for period is capital letter T, girls, okay, not small letter. Please don't use small letter at all because small letter is for time. Capital letter T is for period. So T, capital letter, equals T time over number of cycles. So you count the number of cycles and time. Okay, when you divide time over number of cycles, you get the answer for period. The unit for period is the same unit for time. Okay, what it equals, it is in seconds. Okay, the second thing, frequency. Frequency is the number of cycles an object completes during 1 second. So here in 1 second, I don't care about the cycle, I care about the time now. In 1 second, so I have a stopwatch. I start the time, then the object starts to move. So, and then I stop the stopwatch in 1 second and I see the distance or how many cycles the object has finished in 1 second. Okay? This is the meaning of frequency, the number of cycles an object completes during 1 second. Frequency is the inverse of the period. Okay? The unit of frequency is 1 over second. We call this unit hertz. Okay, H capital letter Z. This is the unit for frequency. The formula, it's the opposite of the previous formula. Period, time to complete one cycle. How many cycles in 1 second? How many cycles in 1 second or a specific time? Clear? So what's the relation between period and frequency? The relationship between the period and the frequency is expressed in the following equation. Period is 1 over frequency. Frequency is 1 over period. Okay? Because sometimes they give you frequency, they ask you to find period. What do? You just divide 1 over frequency. You get the answer for period. Let's see this example together. An object completes 20 revolutions. So as I said, revolutions, you have to know from this word that we are talking about circular motion, revolution, cycle, circle, rotation. So, round, circular motion. In 10 seconds, this is the time, 10 seconds. Here the number of cycles and here time. Determine the period and the frequency of this motion. Just use the formulas, direct. So, first thing is what? Period. Period, we said the formula for period is what? T capital letter equals time over number of cycles. Time is 10 seconds over number of cycles, that is here 20. So the answer is 0.5 what? Seconds. We said the formula for period is, the unit for period is second. Frequency, now you can solve it in 2 ways. The first way, you can use the normal formula, frequency, number of cycles over time. So here we have 20 over 10, the answer is 2 hertz. Or you can just say period equals 1 over frequency. Frequency equals 1 over period. So the period is 0.5, 1 over 0.5, the answer is also 2 hertz. Okay? Good. Now, we want to talk about velocity. Now, velocity in circular motion, what do we call it? Tangential velocity. I don't come and ask you find the velocity for the object in circular motion. No, I will say find tangential velocity. Velocity is constant in uniform circular motion. However, when an object is posed frozen for an instant of time, it will have an instantaneous velocity vector with a specific magnitude and direction. What does it mean? Look, here I have an object moving in a circular motion. At any moment, if you just stop the motion here or you freeze, for example, what do you see? That the object at this moment has a velocity. The magnitude of this velocity is constant, but the direction of it is not the same as the previous direction, not the same as the next direction. Okay, so the direction is changing all the time, but the magnitude stays the same. This velocity we call it tangential velocity. And when an object follows a curved path or circular motion, the instantaneous velocity is referred to as tangential velocity. So if you find the velocity here, you know that this velocity is the same as this one. The same magnitude at any point. Okay? So what do we call the velocity in circular motion? Tangential velocity. Look girls at this figure. Do you know why its name is tangential velocity? Tangential? Think a little bit. Tangential is from tangent. You know what does it mean tangent in math, right? Tangent is straight line that touches the circle at one point only. This is the meaning of tangent. So here, yes, look at this vector, for example, it touches the circle only here. This one, so this is a tangent. At any point, it is the velocity vector is what? A tangent. That's why we call it tangential velocity. Let's see. It is apparent that although the direction of tangential velocity is changing, its magnitude remains constant. We said that before. Now, how to find the magnitude of this tangential velocity? We use the normal formula. Velocity equals what? Distance over time. We know this formula. We used it a lot before. Velocity equals distance over time. Here, what is the distance in circular motion? We said one cycle, one revolution. What is it? Circumference. Circumference. What's the formula for circumference for a circle? 2 pi r. 2 times pi times the radius of the circle over time. Here, what do we call this time? Period. We said the time for one circle is what? For one cycle, we call it period. So this is the formula for tangential velocity. 2 pi r over period. Okay?